Hello everyone. In this video I'm going to teach you fundamental principles of counting. It is a kind of introduction for permutation and combination. So before we go to the principles of counting, let us try to revise your previous lesson, probability of an event. Previously, in case of probability, you have seen what means experiment, which is a process of rolling a die or tossing a coin as an example, or drawing a card, and the outcome is a possible outcome or result. For example, after roll a die, the outcomes are either 1, 2, 3, 4 or 5 and 6. These are outcomes, and sample space, it is a set of all the possible outcomes. You have to put it in a brace to say sample space. This is going to be a sample space, but without brace we call it outcome. And the event is the desired outcome. Like for example, after rolling a die, observing an even number. What are they? 2, 4 and 6. This can be an event. So this is your previous lesson, what means experiment, outcome, sample space and event. Should not be confusing. After that, probability of an event also discussed in your previous lesson. The probability of an event is the same as the number of event divided by the number of sample space. We can see this by examples. First of all, the first example here, it says when a fair coin is tossed, obviously the outcomes are either head or tail, but consider an experiment of tossing a fair coin twice. So if you toss two coins one after, it's okay. The possible outcomes are both can be head and head and tail, or tail and head, or tail may appear. So 4 possibilities are there. For one coin it will be 2. For 2 coins it will be 4 possible outcomes will be there. The sample space will be the same. This outcome will be, we can put it in a brace. That's going to be the sample space. And the next one, it says give the event of H appearing on the second row. What are they? HH and TH. There will be 2 possible events we can have here, because in the second head appearing. In case of both head also appear, there is H in the second, and tail head also. And give the event of at least one tail appearing. One tail appearing means just omit the 2 head. So one tail appear here. So there that we can have 3 events this time. The next example, a box contains 4 red, 4 red and 5 black. So if one ball is drawn at random, what is the probability of getting red and black? It says, first of all, 4 plus 5 will be 9. That is the number of sample space. Don't forget the total possibilities. We have 9 chances. So the probability of red will be, red balls are 4, so 4 over 9. And the probability of black will be, we have 5 blacks, so it's going to be 5 over 9. Easier examples because it's revision. The next one, if a number is to be selected at random from the integers 1 to 10. We have an integer 1 to 10 means 1, 2, 3 until 10. That means the number of sample space will be 10. That is the total possibilities. So what is the probability to be odd? How many odd numbers are there? The odd numbers, obviously 1, 3, 5, 7 and 9. So they are 5. So the probability of being odd will be 5 over 10. Or we can say it's 1 over 2, or we can say 0.5, or it's 50%, or we call it even chance. 50% means even chance. The next one, what is the probability of being divisible by 3? Divisible by 3, what are they? 3, 6 and 9. Those are multiples of 3. So the probability which is divisible by 3 are 3 chances we have out of 10. This means 0.3 or 30%. This is unlikely. So this is some kind of revision. Now let's get back to our main lesson, fundamental principle of counting. What is the first one? let us see one by one. The first one, it says multiplication principle. What does the multiplication principle says? If an event can occur m different ways, and for every m, if there will be another event which is n different ways, then both events can occur in the order m times n ways. So better to see by example. For example, it says here, suppose Nuria wants to go from Harar via Redwa to Addis Ababa. That means her final destination will be Addis Ababa. But there will be, at the middle, there is another town, which is Redwa. There are 2 minibus from Harar to Redwa and 3 buses from Redwa to Addis. You see, the first journey, there will be 2 possibilities, 2 possible transportation systems are there. From Harar to Redwa, 2 minibus, and from Redwa to Addis Ababa, it's going to be 3 possibilities. So how many ways, in how many ways she can travel to from Harar to Addis Ababa? Okay, let us see it. Okay, so this is going to be the rough sketch. How does it look? She is in Harar. Here she is. Her final destination is in Addis. So, but from Harar to Redwa, there will be 2 possible way of transportation: minibus 1 and minibus 2. Again, from Dre to Addis Ababa, it will be 3 possibilities. So, in how many ways she can go to Addis? From Harar to Dre, she can go with minibus 1 and by bus 1, or M1 B2, or M1 B3. The other way, M2 B1 and M2 B2 and M2 B3. So there will be 6 chances. 6 different way of transportation are there from Harar to Addis. First of all, from Harar to Dre, if you use M1, after that 3 possibilities. Again, for M2, 3 possibilities. So therefore, generally, we can say 2 multiplied by 3, which is 6. So when you come back and see the definition, it says multiplication principle. What does it say? If an event can occur in m different ways, and for every such choice of m, if it has another n possibilities or different ways, so we can multiply m by n. Better to add another example. Here it is. What does it say? Suppose there are 5 seats. 1, 2, 3, 4, 5 seats we have in a row. In how many different ways can 5 people seated? There are 5 people, don't forget. So what to do? First, bring the first person, and how many possible ways, or how many possibilities, in how many ways we can let him sit? In the 5 different ways you can let him sit in the first place, or second one, or third, or fourth one, or the last one. So the first person, he has 5 chances. That means one of the chair is already taken now, and 4% left. Now the next person, he has 4 chances again. We will multiply. And the third one, because the second will be taken, the third person also, he has 3 possibilities. So multiply by 3, then by 2, then by 1. The number of chair is reducing, also the number of people also the same manner. So the number of way of arrangement will be 5 times 4 times 3 times 2 times 1, which is going to be 120. 5 4 is 20 times 3 is 60 multiplied by 2, 120. So we can let them sit in 120 different ways. This is a way of arrangement. Later on we'll come back to permutation, and it's going to be easier. The next example, suppose that you have 3 coats and 8 shirts and 6 trousers. So in how many ways, or in how many different ways can you dress? 3 coats means you can say C1, C2, 3, 3, and 8 shirt means S1, S2 until S8, and 6 trousers T1, T2, T3. So in how many ways you can wear? If you wear C1 first, it can go to S1, and S1 goes to T1, or S1 with T2 and S1 with, you see. So for C1 only, C1 and S1, we have 6 chances. So generally we cannot plot each and everything. What to do? 3 multiply 8 times 6, because they are going together. So when you multiply, it will be 144. So he can you can wear 144 different ways. So this is a principle of multiplication. The next one is a principle of addition, or addition principle. What does it say? If an event E1 can occur m ways and another event E2 can happen in n ways, then either of the two events, remember here it says either of the two, means it's going to be just or, either of the two, either m or n, or either m event 1 or event 2. So we can find by adding. For example, look here, the example is better. A question paper has two parts. There will be two parts, part 1 and part 2. When one part contain 4 questions, the first one is 4 questions and the second one it has 3 questions. So if a student has to choose only one question from either part, so in how many ways he can do it? If he choose from the first one, how many chances? He has 4 chances. If he choose from the second one, he has 3 chances. But totally, how many chances he has? 7 chances. So this is addition principle. But he can choose only 2 questions, I mean 1 question. But from either of the two, means either the first one, 4 chances, or the second one, he has 3 possibilities. Together, 7 way of choosing mechanism he can have. The last one, it's combined counting principle. What does it say? Better to see the example first. Combined means, addition and multiplication. A question paper has 3 parts: language, arithmetic, and aptitude. Okay, that means there is language, arithmetic, and aptitude, 3 parts. The language part has 3 questions and arithmetic 6 questions, and aptitude will be 5 questions are there. But look, the question after this, here is the main point. If a student is expected to answer 1 question from each of 2, 1 question from each of 2 means he has to answer from the 2, language and arithmetic, or arithmetic and aptitude. Anyways, what does it say? It continues from each of 2 of the 3 parts, with arithmetic being a compulsory. Means arithmetic is a must to take this one. So you can combine arithmetic with language. This is one way. The other way is arithmetic with aptitude. So when you combine arithmetic with aptitude, they are going together. It's a must. So that means 3 multiplied by 6 chance he has. Plus, if he can choose arithmetic with aptitude, he can have 6 multiplied by 5, because he can choose only 2 questions. I mean one question from the 2. Either arithmetic and language, they are going together. Like you can consider this one like 1. That means how many possibilities he has? 3 multiplied by 6, or arithmetic with aptitude 6 multiplied by 5. So that he has 48 different way of choosing. So here we applied multiplication and addition. So this is combined one. Let us see some exercise. The first question here, it says, in an experiment of selecting a number from 1 to 10, which one of the following cannot be an event? Obviously the answer will be D, because the number 0. It says from 1 to 10, there is no number 0, so this cannot be an event. But the number which is even and prime, yes, there is, which is 2. The number even and multiple of 2, 5. It is 10, obviously. And the number which is a multiple of 3, 3, 6, and 9. So that can be the answer. When you go to the next one, in an experiment of tossing 3 coins, if you toss 3 coins, the possibilities are head, 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 or head, head, tail, or head, tail, head, or head, tail, tail. The first one being head, we can have 4 chances. What if the second one, the first one, make it tail? Tail, head, head, tail, head, tail, 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 head, and tail, tail, tail. So we have 8 chances are there, to the power of 3. If you toss 3 coins, to the power of 3 possible outcomes we can have, which is 8. So determine the sample space. The sample space is this one, the set of. You can put it in a brace, all. Okay, what about C? What does it ask us? I mean B, find the probability of getting 2 heads, exactly 2 heads. It doesn't say at least 2 heads. So 2 heads are Here it is, head, tail, and here also 2, and the third one here it is. So we can have 3 chances, 3 out of 8. So the answer for B will be 3 over 8. This is the answer for B, the probability of getting 2 heads. Okay, let's go to the next question. A box contains 2 red and 3 black. If 2 balls are drawn at random, determine the possible outcomes. 2 balls will be taken out. That means both can be red, or red and black, or black and red, or black and black. These are the possibilities. Determine the possible outcomes. This is a possible outcome. The answer for A is this one. B, find the probability of getting 2 red. 2 red means just 1 chance we have. So the answer for B will be 1 out of 4. And C, find the probability of getting 1 red, 1 and 1 black. These are 2 chances we have. So the answer for C will be 2 out of 4, or 1 over 2 we can say. Okay, the next question. Suppose you have 6 different books. In how many different ways can you arrange these books on a shelf? 6 times, 5 times, 4 times, 3 times 2. It's a kind of permutation. So it will be 720 ways. As we said before, there were 5 chairs and 5 people in the example. So in how many ways we can let them sit? The 5 people in 5 chairs. The first person, he has 5 chance times. You can omit that. The second person, he has 4 chance. It goes like that. The same manner here we have 6 books and we have 6 places. So in how many ways we can? The first book, okay, he has 6 places. It has 6 different places, so 6 chance. The second one, it has 5, and the next one 4. It goes like that. Lastly there will be times 1, but we can ignore times 1. It doesn't have effect. So it will be 720 different ways we can arrange. The last question. There are 3 gates to enter a school and 2 doors to go into the classroom. That means outer there will be 3 ways, and then again 2 ways for the classroom. This will be the classroom. So in how many ways someone can enter to the classroom? Of course 3 multiplied by 2, like that of Harar to Dre, then Redwa to Addis Ababa. From Harar to Redwa there were 2 ways of transportation, and then from Redwa to Addis Ababa there were 3 ways of transportation. We did 2 multiplied 3, which is 6. The same manner here, to enter to the school compound there will be 3 gates, so 3, and after that to enter to the classroom there will be 2 gates, so multiply, which will be 6 different way of entrance will be there. The last question will be this one. It says in a classroom there are 50 students, the total one, and 27 female. 27 female means obviously the male will be 50 minus 27, which will be 23. 23 males are there. So if a student is selected at random, so what is the probability of getting male? So the probability of male will be 23 over 50. You can change this one into percentage. How? Multiply by 2, which will be 46 over 100, which is 46%. That is unlikely. So these are the first introduction part for permutation and combination. I'll be back with permutation and combination in the next lesson. Thank you.